Hi guys, and welcome to Jump Mathematics. In today's video we're going to be learning how to graph in one dimension, which includes the one-dimensional number line, graphing one-variable equations, and solving one-variable equations by graphing. Then we're going to move on to graphing in two dimensions, which includes the coordinate or Cartesian plane, graphing linear equations, and solving linear equations by graphing. So to start off, we'll be talking about the number line. And as you may guess from the name, it's a line with an arrow on each end, okay? And then we're going to put a hash down the middle, and this represents a number. So for our number line, it's going to be 0. Doesn't have to be, but that's what I want it to be. And then we're going to move on with little hashes. They have to be of even increments. And then we're going to label them. So for this one, I want it to go up by 1s. There we go. Now we're only missing one more thing on this number line, and that's what variable we'll be graphing. You can pick any variable you want it to be. For this one, I want it to be x. And you put the variable on the positive end of our number line. So now we're going to learn how to graph one-variable equations and inequalities. So we'll start off with x equals 0. So I have my number line. First of all, our variable is x, so we're going to label that x. Then I'm going to draw a line, and I'm going to write 0. And I don't really have to put any other points on. I can, but it doesn't really matter since I'm just graphing 0. And I just put a solid point right there. So now moving on, we have x equals 1. So put x there. And like I said, that point doesn't have to be 0. I can make it any point I want it to be. So I'm going to make that 1, and then I'm going to put a solid point right there. So now I know x equals 1. So moving on, I have x equals -5. Now I'm going to put my point here, and I'm going to call that 0, and then I'm going to go, before I said that it doesn't have to go in increments of 1, it can go in increments as however many you want it to be as long as they're even. So I'm going to call this -5, and then likewise over here will be -10. Then I'll graph it. And I'll put my point right there. So now we know x equals -5. Moving on. From just singular points, we have x is greater than or equal to -2. So again, I'll put my x there. And I'm going to start my 0 here. Then I'm going to go -1, -2, -3. Label it. Now, to show that x can be anything greater than or equal to -2, I'm going to put a solid point here, meaning it can equal -2, and then I'm going to draw a line on like this, and then an arrow just like that, saying that it can also be greater than -2. So now, I have x is less than 0. So put my x here, and let's put my 0 there. And I really don't need any other points because I can just draw my line on like this. And because it cannot equal 0, it can only be less than 0, we put an open point right there. So that means it's less than or equal to 0. So now we have x is less than 0.5 or x is greater than 1. So first of all, I'll put my x there, and then I'm going to label my 0 there. Then I'm going to go 0.5, 1, 1.5, and these don't really matter, but I'll put them on just because. So we'll label it. And like I said, it doesn't matter what increments you do as long as they're even. just like that. So x is less than 0.5, so it can't equal 0.5. So that means open circle, and then we draw an arrow to the left. Or x is greater than 1, which means open circle because it's greater than, not greater than or equal to. And then I draw a line on like that. So x can be anything less than 0.5 or anything greater than 1. But it can't be anywhere between 0.5 and 1. So next, we have -3 is less than x, which is less than or equal to -2. So put my x there, and I'm going to put 0 there. Okay. Now this one, I can rearrange it to say x is greater than -3 or x is less than or equal to -2. Sorry, not -2, less than or equal to 2. But we write it like this because x is in between those two values. So, because it doesn't have a line under it for equal to, that's an open circle, and this is a closed circle because it can also equal to. And then we just draw a line connecting them, just like that. So now, we have our x is less than 0 or x is equal to 4. Now this one's a little weird. You don't often see these. So I'll put my 0 there, and I'll go 1, 2, 3, 4. Just like that. And can't equal 0, so it's an open circle. And then an arrow to the left because it can be less than 0, or it can be equal to 4. So it's just a point, just like that. Now finally, we have x is not equal to 0. This means x can be any value other than 0. So you might have already guessed it. We're going to put a 0 there. And because it's not equal to 0, we put an open circle and then arrows to both sides, meaning that it can be anything other than 0. That's how to graph one-variable equations and inequalities. So next we're going to learn how to solve one-variable equations and inequalities by graphing them. So just like before, we'll put our x on it, and I'm just going to do this for all of these, because all of them are x's. So now, let's figure out how we want to label the graph. So I see a greater than or equal to 0, and I see a 2. So I'm going to put the 0 on this side. I'm going to go 1, 2. Just like that. Then, let's see, what I'm going to do is I'm going to make the top ones black, and I'm going to make the bottom ones brown. So we'll start with the brown one, the black one. That's going to be 2, just like that. And then have a closed circle just like that, and a line that goes just like that. So now to solve it, we need to come up with a new equation that is true for both of them. So we have to figure out where they both overlap. And right here, the only place they overlap is at 2. So our answer is x equals 2. Now, we have x is not equal to 0 and x is greater than 0. So I'm going to start by making that my 0. And since 0 is the only number, I don't need any other numbers in this. And see, it's going to be like that. And then for this one, we have x is greater than 0, open circle, and we'll go like that. So, where do they overlap? X is greater than 0. Just like that. And there's our answer. So let's move on to the next one. There we go. And then we'll graph it. So top one is black. So I have, oh that's nice, we have equal done. So it's just a closed circle, just like that. And now we move on to this one, open circle, just like that, just like that. Now your answer won't always be one of the two equations that's given to you. This is the case in this one. So we have to come up with a new equation that satisfies it for when both of them overlap. So I see they overlap starting at -3 and they go up to 1 and they can't include 1 and then they go from 1 to 3. So we'll go -3 is less than or equal to, because that is an equal to, x, which is less than 1, or, since we have two different spots where they overlap, we put an or. 1 is less than x, which is less than or equal to 3. So we have an and equation and an or inside of an or equation, just like that. It's a very complex one. You won't see many of those, but it's good to know. Moving on, we have x is equal to -1 and x is equal to 2. Like that. And let's see, let's graph my -1. And let's graph my 2. There's no place where they overlap. There's no answer to this one. So you just write no solution. Sometimes they give you problems where there aren't any solutions to it. Moving on, x is less than 4, and then our second equation is x is greater than or equal to 0. Just like that. And let's graph it. X is less than 4. X is greater than or equal to 0. So remember, the equal to's are solid dots, just like that. And we'll draw a line on like that. So now where do they overlap? This is going to be one of those where we come up with a new equation that isn't one of those. So I see they both overlap at 0, and they stop overlapping at 4. So our answer will be 0 is less than or equal to x, which is less than 4. Finally, just for fun, one with big numbers. X is greater than or equal to 100, and our second equation is x is less than 1,000. So we don't always have to start with a 0. I'm going to make this my 100. We don't always have to have increments of 1. So I'm going to make my increments of 100. So we'll go 200, 300, 400, 500, 600, 700, 800, 900, 1,000. There we go. And now we can graph both equations. So, solid dot there, and a line on like that. And now let's see, it's an open dot because it's less than but not equal to. And then a line just like that. So where do they overlap? 100 is less than or equal to x, which is less than 1,000. It's a fun one with big numbers. So next up, we're going to learn how to graph in 2 dimensions. This is for when you have 2 variables. So our two-dimensional equivalent of the number line is a coordinate or Cartesian plane. You can call it either one, coordinate plane or Cartesian plane. And it starts just like a number line. We have a line just like this with arrows on the end, and we'll call that our x-axis. Now we need one for another variable. We'll go next in the alphabet, we'll call it y. And we'll just go like that. Perpendicular to this line, so it makes 90-degree angles. And on the positive side, we call it y, just like that. Now this point right here, it's a very special point. It's the only place where these two axes intersect, and it's at 0, 0. It's called the origin. So our first number in the coordinate plane, like this for different points, this represents x. Let me get a different color for this. This represents x, and this represents y. So if you're ever getting given a pair of numbers like this, with a comma in between, and you're told that it's a singular point on a two-dimensional plane, then you know the x value comes first and the y value comes second. So then after that we can label it just like this with increments of however big we want them to be. Just like that. We'll go by ones. Just like that. So if we wanted to graph 0, 0, we would put it here, just like that. So next up, we're going to learn what a linear equation is and the three different types of linear equations. So as you can guess, they'll make a line, just like the name suggests right there, the word line and linear. And in order for it to make a line, it'll need two variables. So we'll use x and y just like we did in the coordinate or Cartesian plane. So we'll start with this form. Y equals mx plus, not minus, plus b. So you may be asking, well, you said there's two variables. I recognize the x and the y, but why is there an m and a b? The m just represents a number called the slope. And the slope is just change in y over change in x. These little triangles mean change. So it tells you how much y changes every time x changes. This b is called the y-intercept. That just means when x is 0, what will y equal? So it crosses the y-axis at b. This is called slope-intercept form. Which is why we have the slope and the intercept. So next up will be the point slope form, which goes y minus y1 equals m times x minus x1. So you recognize the m, and yeah, that just does mean slope. It's exactly the same as here. But you may be asking, what's the y1 and the x1? Those are just two values in a single point on the graph. So if you know one point on the line and you know the slope of it, you can write it in point slope form. So we'll have to be given our point x1, y1, and just like that we can just plug that in. Y minus y1, not plus, equals the slope, so m times x minus x1. And that is called point slope form. Oops, not form, which is why we have a point. and we have the slope. So finally, we have standard form. This is represented ax plus by equals c. The a is just a coefficient that goes on the x, the b is just a coefficient that goes on the y, and the c is just a coefficient. This is a rearrangement of that, or you can rearrange this into that or that. All of these, you can, if you know one point on the line, whether it's the y-intercept or whether it's a point like this, and if you know the slope, or if you know the standard form, then you can just change it into any form that you want. Hi guys, if you enjoyed this video, please check out jumpmathematics.com, where we have hundreds of practice problems, several practice tests, and tons of instructional videos all for free. Thanks for watching, and I'll see you in the next video.